at IRS, Indian Institute of Shipping, under the guidance of Ramkumar Joga, a senior surveyor, and an assistant surveyor, P. Deepika, alumni office. I have worked in IRS in 2 months. My first month work is concentrated with learning these topics.
Go to your work.
Yes. So prediction of resistance, power, empirical methods. So there are many methods for prediction of resistance. They are numerical, empirical, model testing, etc. First of all, let me give a quick glance of empirical methods. There are many empirical methods such as HMM method, Rotmeister method, Watanabe, Korn and Ferguson, Dixon, Wright, Clauser. These all depend on shape factor of the ship or any body that's being simulated. Next, these are the foundations of all the empirical methods. Fruits method, Hughes approach, IDTs 1957, Dixon friction line, etc. And these are the foundations used. These are the main foundations that are being used at present in the industry for the calculation of coefficients of friction and pressure, etc. So CFD simulation setup. CFD simulation setup involves several steps such as importing model, mesh generation, domain setup, and physics setup, visualization and data analysis, setting solver parameters and shopping criteria, running the simulation, post processing. Importing model refers to importing your CAD drawing, and mesh generation should be done in such a way that boundary layer should be fine meshed and gradually increasing the mesh size. And domain setup and design. Physics setup involves all the physics equations and solvers what we are using. Visualization and data involves use the graphs and plots. And setting solver parameters and shopping criteria is nothing but setting convective timescale or number of iterations, etc. And then running the simulation and then extracting the results. So CFD behind physics. Generally, Reynolds equation is very much useful for us according to in fluid mechanics or in resistance and propulsion, etc. But Reynolds average and Navier-Stokes equation use the fluctuating components also very finely. So as we can see here, changing fluid velocity over time is depicted by this term, and this is the mean convention in space, and this gives pressure, viscous stress, and Reynolds and turbulent stress. This equation is mainly used in CFD. Actually, the behind system computes this equation with the number of iterations for each and every step, and then gives the result. These are the types of physics equations or physics methods that can be used behind. Other than Reynolds average Navier-Stokes equation, we can use detached eddy simulations, large eddy simulations, direct numerical methods, and potential flow plus corrections. These involve potential flow plus corrections means potential flow is generally concentrated with inviscid and incompressible and such. But in practical world, we deal with viscosity. So those are nothing but corrections. So in our domain, Reynolds average Navier-Stokes equations and potential flow plus corrections are mainly used for our domain. So more than this gives approximate results with less error. So I have used Star CCM Plus as the CFD tool for simulating my vessel. This is the top view of the vessel simulation. This is the Kelvin wave pattern. Distance is nothing but the opposition offered to the ship as it moves through the water. Then the wave pattern is generated as like this. Next, we check for residual convergence by meshing it finely. This mesh should be done in boundary layer, very fine mesh is done, and as we go far away from ship, it becomes broader and core mesh. This is volume fraction. By this, we decide how much bow is immersed in water or emerged and At this area we can see some color change and variation. This is nothing but free surface. At this area much resistance is offered to the ship as it goes through two multi-physics domains, that is air and water. So the conclusion, sir, I have learned everything, resistance and propulsion. I have revised my basic to deep concepts, and then CFD simulations are performed for estimating vessel's resistance in model as well as full scale. And CFD model scale results of resistance are extrapolated using friction line. So when extrapolating the results, I have seen that model scale extrapolation results are very well and it's very accurate. But full scale results are not matching with the standard results. Why? Because there is actually a wall y plus which is involved. So let us consider the top view of the ship. This is the mesh being done. So this is the first layer of our mesh. This distance is nothing but y. So on some scientific calculations, y plus is nothing but given by y into u by nu. This is nothing but viscosity. This is nothing but velocity. So according to ITPC regulations, y plus should be in between 30 to 300. As I have said, for the model scale, I have gained the y plus as 43 to 50 as its level. But in case of full scale resistance, I have obtained it as in thousands. I have researched on this and I have come to the conclusion that there is some error with the model. And so model scale results are used for calculating full scale by extrapolated using the friction line. So that's what I have mentioned here. Y plus was in the range of 35 to 55 and greater than 1000. So mesh sensitivity studies would yield in better results, and wave profile are compared with marine results. So I have done also self-propulsion simulations and the deviation in results are 9% because this is due to I have run it for the full scale resistance. Actually we do resistance calculation and then keep an actuated disc behind the ship and then run the self-propulsion test. So I have obtained this 9% error, but further refinement in mesh may give and yield better results. This is what I have done. Thank you.